The water footprint of animal products versus crop products. In a recent study, Mekkonen and Hoekstra, back in 2010, showed that the water footprint of any animal product is larger than the water footprint of a wisely chosen crop product with equivalent nutritional value. They calculated that 1 liter of soy milk produced in Belgium had a water footprint of approximately 300 liters, whereas the water footprint of 1 liter of milk from cows was more than 3 times larger. The water footprint of a 150-gram soy burger produced in the Netherlands appears to be about 160 liters, whereas the water footprint of an average 150-gram beef burger is nearly 15 times larger. Table 1 shows the global average water footprint of a number of crop and animal products. The numbers show that the average water footprint per calorie for beef is 20 times larger than that for cereals and starchy roots. The global water footprint of animal production amounts to 2,422 billion cubic meters per year, with 87% being green water, 6% blue, and 7% gray. 1/3 of this total is related to beef cattle, and another 19% is related to dairy cattle, according to Mekkonen and Hoekstra, 2010. The largest fraction, 98% of the water footprint of animal products refers to the water footprint of the feed for the animals. Drinking water for the animals, service water, and feed mixing water account for 1.1, 0.8, and 0.03% respectively. The water footprint of a meat versus a vegetarian diet. Dietary habits greatly influence the overall water footprint of people. In industrialized countries, the average calorie consumption is about 3,400 kilocalories per day, according to FAO in 2011. Roughly 30% of that comes from animal products. When we assume that the average daily portion of animal products is a reasonable mix of beef, pork, poultry, fish, eggs, and dairy products, we can estimate that 1 kilocalorie of animal product requires roughly 2.5 liters of water on average. Products of vegetable origin, on the other hand, require roughly half a liter of water per kilocalorie, assuming a reasonable mix of cereals, pulses, roots, fruits, and vegetables. Under these circumstances, producing the food for 1 day costs 3,600 liters of water. For the vegetarian diet, we assume that a smaller fraction is of animal origin, not zero because of dairy products still being consumed, but keep all other factors equal. This reduces the food-related water footprint to 2,300 liters per day, which means a reduction of 36%. Keeping in mind that for the meat eater, we took the average diet of a whole population, and that meat consumption varies within a population, larger water savings can be achieved by individuals that eat more meat than the average person. From the values above, it is obvious that consumers can reduce their water footprint by reducing their volume of meat consumption. Alternatively, or in addition, however, consumers can reduce their water footprint by being more selective in the choice of which piece of meat they pick. Chickens are less water-intensive than cows, and beef from one production system cannot be compared in terms of associated water impacts with beef from another production system. The local and global dimensions of water governance. Problems of water scarcity and pollution always become manifest locally and during specific parts of the year. As a result, all countries import and export water in virtual form, that is, in the form of agricultural commodities. Total international virtual water flows related to global trade in animal products add up to 272 billion cubic meters per year, a volume equivalent to about 1/2 the annual Mississippi runoff. Not only are livestock and livestock products internationally traded, but also feed crops are traded. In trade statistics, however, it is difficult to distinguish between food and feed crops because they are mostly the same crops, only the application is different. Worldwide, trade in crops and crop products results in international virtual water flows that add up to 1,766 billion cubic meters per year. Until today, water is still mostly considered a local or regional resource, to be managed preferably at the catchment or river basin level. For animal products, it is much more difficult to tell whether they relate to such problems because animals are often fed a variety of feed ingredients and their feed supply chains are difficult to trace. Hence, unless we have milk, cheese, eggs, or meat from an animal that was raised locally and that grazed locally or was otherwise fed with locally grown feedstuffs, it is hard to say something about which claim such a product has put on the world's scarce freshwater resources. The increasing complexity of our food system in general and the animal product system in particular hides the existing links between the food we buy and the resource use and associated impacts that underlie it.